Good morning, everyone. I'm Pawan Soami, Technical Product Lead COMSOL India. I'll be talking about leveraging multiphysics simulation for new mobility in the context of automotive acoustics. So let me briefly talk about the agenda for the talk. So I'll be introducing the COMSOL Multiphysics software and talking about a few case studies related to automotive audio system and acoustics metasurfaces. And then I'll also be talking about the application builder, a unique functionality in COMSOL, and then again a user story based on that. And after that, I'll be covering few muffler and resonator examples, and then the NVH for gearbox and electric motor. So with this agenda, let me quickly introduce the COMSOL Multiphysics. So this is the COMSOL 2021. On the right-hand side, you can see various COMSOL offices and COMSOL distributors. COMSOL is a modeling and simulation software. It has ready-made physics interfaces, various generalized mathematical interfaces, and then you can import built-in CAD geometries. There are several add-on modules for various physics interfaces, and then it has live link products to connect with partner softwares. Then it has various types of development tools, the model builder, the most common one, and then the recent additions of physics builder and application builder. And then you can also deploy these apps using the COMSOL compiler or the COMSOL server. So these things we will discuss in a little bit more detail. So this is how the COMSOL looks like. So it has the multiphysics platform product, which has various add-on products like electromagnetics, structural acoustics, optimization, etc. So today our focus is on acoustics and a little bit on a structural part to model all those automotive acoustics applications in COMSOL. Then more importantly, it also has the equation-based modeling where you can write your own equation. And then apart from this modeling all these physics individually, you can combine all of them and perform a multiphysics simulation. So this is basically a model builder part. And the recent addition is the applications building. So application is nothing but you have a complicated COMSOL model. Then on top of it, you add your own user interface. And you can also optionally add a report generation functionality. And once you do this, you create an app. Now this app can be compiled and created in a .exe file, or it can be deployed on a COMSOL server. So this is the COMSOL window. That is how the software looks like. It has this application builder button. It has a ribbon having various buttons. On the right-hand side, it has a graphics window. Left-hand side, it has a model builder window, which shows all the steps what you perform in general while creating a model, starting from geometry, material, physics, mesh study, and results. And then in between, you have settings window to set various parameters. So I'll not go into detail. I'll just quickly introduce the software. This is how the product suite looks like. This is the COMSOL Multiphysics platform product. And then it has all these add-on products. So all the add-on products are divided in different suites. So it has electromagnetic suite, fluid and heat suite, structure and acoustics. So today our focus is a little bit on this part. Then chemical suite, multipurpose and interfacing. And then apart from that, we have these two deployment products for applications, which I already talked about, COMSOL Compiler and COMSOL Server. Now, let me talk about the case studies here. So first one, what I'm talking about is by the Herman International France. So they basically use COMSOL for designing luxury car or audio systems. So the challenge here is now they are looking for designing audio system which can mimic the audio environment like in concerts, stadiums, sound studios, etc. So we want almost that type of quality even in the car, especially in the luxury cars. So, and the design challenges are in the cars, there are a lot of surfaces with reflections and absorptions. So they need to really simulate the internal environment. And from expectation point of view, they really need to come up with more and more expectation and more better design using these simulations. So let's see what they have done. So they perform the COMSOL multiphysics acoustics analysis in the car cabin. They also use the application builder for what I'll be talking about. So, and then using that application builder, they made an app which really helped in their design, which helped in designing in a quick manner, and which also predicted and validated the design. And they could also enhance their original design using the app. So on the right-hand side, you can see the car cabin simulation, where the sound pressure levels are shown for different placements of these speakers. So there are more details about this. I'm not going through all of them. So this user story is available on our website, so perhaps you can browse through it. Second one is about the École Polytechnique Switzerland. So here, the sound of perfection thanks to the modeling of acoustic metasurfaces. So they basically model metasurfaces to enhance the acoustics in different environments, again, like concert halls, soundproof homes, or the damp, irritating noises. Right. So again, for this, they use structural mechanics modeling as well as acoustics modeling in COMSOL. And this is also published in the COMSOL News 2018. So you can perhaps refer more details there. So on the right-hand side, you can see the reflected sound pressure levels by the metasurfaces. So here they have modeled the metasurfaces with a 32 by 32 unit cell, and then using that at 350 hertz, what is the sound pressure level? It can be seen on this figure. Let me quickly talk about the application builder. As I already mentioned, the application builder is nothing but if you already have a model builder, there is just a single button. Through that, you can create an application where you can choose a new form and the new form window. All these things can be defined in a very quick manner. And then from COMSOL GUI, what you see is the app GUI. So app can be as simple as this. You have 2 to 3 inputs. You can have a button. You can get an output. So this really helps in making the process fast, and you really don't need to learn how the entire GUI of the COMSOL software works. So who can create these apps? So basically, simulation specialists can create these apps, and then it can be distributed to all the teams, starting from manufacturing, sales, design, suppliers. So they can basically use this app for simulating and kind of testing various needs in their fields. COMSOL Compiler is basically so there are various ways to using app. One of them is like creating standalone apps. So that can be done using COMSOL Compiler. And once you do that, they become a .exe file. So then there is no license file requirement of COMSOL, and you can just compile on Windows, Linux, and Mac OS. So now one of the example of this application builder is by Mahindra two-wheeler, India. So they use this for modeling the exhaust system of motorcycles. So here the goal was to basically meet regulatory requirements on engine pass-by noise and also satisfy customer demands, which wasn't an easy task. So they decided to create an app for that. So the app can be seen here. So this is the app GUI, which has various inputs here. It has different buttons. You can import files, and then these are the results. So this app really helped them in kind of modeling the noise, vibration, and harshness because of the engine intake and exhaust system. And using that, they could create a lot of results in a quick manner, and they could automate the data processing also. Again, this is the user story, which is available in COMSOL News 2017 on our website, so you can have a more detail there. Let me quickly talk about the mufflers and resonators modeling. So in acoustics, you can model these automotive mufflers. So in this muffler, there's an inlet and outlet, and aim is to find the transmission loss at various frequencies. And this is a simple pressure acoustics model. So on the first figure, you can see the sound pressure level, and on the second figure, you can see the absolute pressure. And then these pressures are frequency dependent. So all these pressures, what you're seeing here is at 490 hertz. So the simulation can be done at various frequencies. So in this model, the simulation is done from 100 hertz to 1000 hertz. At different frequencies, you get a different sound pressure level distribution as well as different transmission loss. Now talking about the muffler modeling, sometimes you also use a perforated plate in the muffler. So there are various ways of modeling perforated plate. So in COMSOL, there is a built-in model for perforated plate modeling, so you can use that. Or the second option here is to do the detailed subsystem modeling of a single perforation. So in this case, the same thing is done. So we have taken the one single hole, and entire hole is not required to model. So the 3D modeling of some sector of the hole is done. And once you do this, you cannot do just the pressure acoustics modeling. You need to do the thermoviscous acoustics, which means you also account for thermal and viscous losses apart from the just pressure acoustics modeling in the muffler. So once you do that, you can find the transmission loss of single hole, and then that can be used as the transmission loss of the perforated plate. So this model is solved basically using both the approaches. One using the default perforated plate model, which is shown in the green color, and then the blue color, and then the thermoviscous acoustics impedance, which is in the green color, which are matching quite well. And they are also compared with the experimental results. Next is the Helmholtz Resonator. So this resonator is basically used for damping the certain segment of frequencies in the exhaust system. So this basically, once you do this, you use the aeroacoustics modeling where the Navier-Stokes equation is solved. And then this is in general coupled with the fluid flow because this is placed in the exhaust system that is solved together with the turbulent flow. So this particular model is solved at different Mach numbers and different frequencies. So results of acoustic pressure can be seen at 200 Hertz here in the Helmholtz resonator. And again, this is 200 Hertz at Mach number 0.1. This is the transmission loss with respect to frequencies at different Mach numbers. So this is Mach number 0, then the frequency transmission loss curve looks like this, the blue one. And as you increase the Mach number, you can see the transmission loss curve is changing. So this is a truly multiphysics example where the fluid flow and acoustics modelings are coupled here. Next is the NVH modeling. So let's start with the gearbox noise. So in this gearbox model, it's a detailed model of five-speed synchromesh gearbox, where first the multi-body dynamics analysis is performed of all the gears. And once the dynamics is computed, you can find the vibration levels in the housing, and then this housing basically emits the noise in the surrounding. So for that purpose, you can model the surrounding domain and you can find the sound pressure level on the housing as well as in the exterior domain. It is also possible to place basically the microphones at different levels, and you can also listen to the noise coming in different direction and also at different distances. In a similar manner, a motor noise analysis can also be performed. So in this motor noise, basically first you can solve the transient electromagnetic forces. And because of the electromagnetic forces, there are the motor body vibrations. And so these are basically solved in a coupled manner. And now because of the vibrations, there are noise emitted in the surrounding. So this is the model of an electric induction motor. So these are the different parts shown here. And then if we take a cross section, these are the induced current density in the rotor and the stator when the rotor is rotating. On the right-hand side, we can see the torque as well as speed curve. So this is the rotor speed and this is the rotor torque. And these are the magnetic flux density as well as electromagnetic forces. So once the rotor is rotating, you can see the electromagnetic flux density. And on the right-hand side, you can see the electromagnetic forces on the rotor. And now because of these electromagnetic forces in the rotor and stator, there are vibrations in the system because this rotor is mounted on a bearing between the rotor and stator and the housing. So now on these two bearings, you can see the forces on bearing 1 and forces in bearing 2 and transverse and axial direction. That gives rise to basically vibration in the entire system, and that vibration gives rise to noise. So now once we extend this model for noise modeling, so you can see the noise in the surrounding. So this is the transient simulation, and in frequency also you can find the same at different frequencies. So this is the sound pressure level at 120 Hertz in the surrounding, and this is the sound pressure level at 120 Hertz on the motor casing surface. So basically this motor noise model involves first the electromagnetic modeling and then the structural modeling in a coupled manner, and then that can be extended for acoustic modeling for simulating noise. Okay, so with this we have reached to the end of the session. So for any queries, you can contact us. You can visit our website www.comsol.co.in/contact. All the user stories what I have talked about, they are available on our website as well as on our booth. So you can reach to our booth and get all the details about the user stories and models shared during the presentation. Thank you very much for attending the session. Have a nice day.